So, yeah, this is a big Latin exorcism exercise. So just had a little bit of a crack at this to see what we could do with it. I did actually have a quick thought yesterday that, hey, this would be really awesome to build an actual recurrent neural network with NX, and that would be really cool. And I could do all the translation that way instead of doing like a little mechanical thing. Maybe next month. Kind of a little bit more work than just swapping letters around. So what Big Latin is a really basic kind of, you put the XA, yeah, whatever, I can't speak it, but there's a whole bunch of rules where you basically put A's on the end of things, and it depends on whether it's got a vowel at the front, so just have a look through them. If a word begins with a vowel sound, you add an A to the end, an X, R, and Y, T at the beginning are considered to be vowels, so there's some special rules there. The word's got a consonant sound, you move the consonant to the end and you put A on the end. And if it's a chain of consonants, you've got to move the whole chain to the end. It's followed by QU, that's a different rule as well. So square turns into S, squay. And if there's a Y after there, that counts as a thing as well. They've got a bunch of tests in here that don't actually implement this stuff here. So I kind of ignored what the rules were and just made the specs pass, which works. Yes, looking through what we've got there in terms of the tests around this stuff, fairly basic as you would think. So first of all, it's dealing with all the vowels. So that was kind of an easy place to start. So we're going to have a look at the code for that. So Apple gets turned into Apple A. So the way that we've got that working is this one here is our code for it. It's got this translate function that does the work. And the tests are actually really sneaky because they test you with single words the whole way through. And you get all that working, and that's great. And then you get down to the very, very, very last one. It's it's got to work with a phrase as well. So you got to refactor all your code. So the trick for new players there. So word is actually the thing that does the work in here. And translates the entry point into there. So what we do is take a phrase, which is just a string. Just do a simple split on that, which is going to split on white space. And then we do a map join by mapping over each term in that phrase by calling the word function that will do the Big Latin translation. Then we just join it with the space. So to drive that, I ended up doing a lot of this the whole way through. So you can do a lot of this with pattern matching. Thing is, if you're writing that out in line every time, it gets to be a pain in the neck really quick. So setting up a couple of guards first up is very, very useful. So we've got two custom def guard Ps there. So def guard P means just a private guard you can use within this module. One's isval, and that just checks to see whether a given character is in that list of characters there. So you notice that they're actually question mark A, question mark E, which means they're code points. So those are actually integers rather than strings for those things, which works because we're going to do binary pattern matching down here to actually pull all that stuff out and make it work. So our entry point into here, first up, got a bunch of different clauses for word. First one, we're going to split with a binary pattern match here to say, grab that whole thing there, and we just want to pull the first UTF-8 character off the front, and then ignore the rest of that. That's what the underscore binary means, where it says it's just a whole string of binary data, we don't care. But that V character, we call the isval guard on it. And if it is a vowel, then we apply the rule where we say, put AY on the end. So if it's a vowel, it starts with that. If it starts with a vowel, put an AY on the end. And literally that's all we're doing there. So we take our original word, just append AY to it. Next one is if it starts with a QU, that's considered to be a vowel as well. Actually, no, that's considered to be a thing that goes to the end. So it's a consonant and a vowel goes to the end. So rest is the rest of that word. So we're splitting on that. So we're saying, okay, anything that starts with Q, like quiet, we take everything after the end of that and just append QU, AY onto the end. So that would be iat, quay for quiet. Last one, actually second to last one here, is another binary pattern match where we're going to pull out something that starts with a consonant, then it's got QU, then we've got a bunch of other stuff at the end. And then we're going to assemble that back into a thing that takes the rest at the start, followed by our first C character there, followed by QUAY. And that would be for something that starts with a consonant and then it's got QU, like square. So square turns into air squay, I think is what it turns out at the end, which I think is one of our tests in here. Maybe they didn't have that as a thing. What is it?
Line 73.
There we are, yeah. So air squay. Square turns into air squay. Then we've got another one here saying if it starts with an X or a Y, then it's got a consonant. Then we've got a bunch of other stuff at the end. Treat that as a vowel. So this is for like X-ray. X-ray is treated as a vowel sound. So X-ray turns into X-ray A, which I think is one of our tests here. Yeah, so X-ray A gets turned into that. So they're all the common cases with the vowel type sounds. Last one gets slightly more complicated where we've got a cluster of consonants. So anything where there's a word followed by another consonant, actually not that one there. So these ones where consecutive consonants are treated as a single consonant. So chair, grab the first two consonants off the front because then we get a vowel off that. That turns into air che. So you grab the rest of the word, put the consonants at the end, then append A on the end. So same with th there, therapy turns into therapy they. THR turns thrush turns into ush three. And school turns into all skay. So we just take a cluster of consonants, put them in the end, then append an AY in the end. So we just do another binary pattern match in there, and we build up an accumulator to do that work for us. This is one where we've defined a default argument for the cluster function. If you've got multiple clauses and you're providing a default argument, you need to provide a head list, like a header row, which is this one here. So we're saying cluster, if you don't pass in the second argument, which is the accumulator, which we do here when we call it. So to start it, we want to have the interface saying, we're just going to give you the word, go and figure out what that should be turned into, dealing with all the clusters. And it starts it off with an empty accumulator. Then as we step through each step in there, we're going to match to see, okay, is it got a consonant at the start and then rest? If we do, call cluster again recursively as a tail recursive function and append the letter that was at the start of the word onto the accumulator. So that's going to build up our list of consonants in our cluster in reverse order. And that'll keep going again. If you've got a bunch of consonants, that'll call again, call again, call again. So then if it's not a consonant, it'll drop down into this clause here. And that's the termination clause. So we're saying, here's our word. That's the accumulator that we've got with all our consonants at the start. This is the rest of the word with the consonants peeled off the front, but they're in reverse order. So we need to then to build the suffix, we need to get that accumulator, reverse it, and they will be individual code points again, because we've done a binary pattern match here as a UTF-8, which will pull it out as an integer rather than a string or a binary. So we call list a string to convert that list of integer UTF-8 code points back into an actual binary string. Then we just append them together and stick the A on the end, and we're done. So looking through our tests here, if we run them, and that works. So that's a very, very, very quick walkthrough of that there. Yeah, the neural network translation using NX, maybe next month. Could be fun to do. You could use a sequence-to-sequence recurrent neural network to do that. And I think it would work pretty well, but I'm kind of not game to implement all that stuff in NX at the low level, which is kind of why I was asking like what if there's any kind of community packages on the horizon. because I'd kind of be okay tackling that in Python with the right libraries, but doing it from scratch, I don't know if my ML skills are quite up to that. So yeah, any questions?
Just going to say congratulations for actually using binary, because most of the solutions I looked at were all regex and doing stuff more complex. People shy away from doing it binary style.
Yeah, binary is really handy. It's super fast. Just because, you know, sort of all that stuff will end up being, you can pack a lot of logic into that and it'll, you know, sort of be interpreted pretty low level in the beam, which is nice. Comes up a lot, especially in the Exercism and advent of code and all that kind of stuff where you've got to do some random string mangling. I use it, you know, fairly often in real work as well. Like, you know, if you want to pull out and do some stuff with, you know, some strings at the front, and it's a good way of doing it.
Yeah, it was a fun challenge.
Yeah.
Have you pushed it up to Exercism?
I haven't yet. I should do that. Need to actually get my login working again. I think I just pulled down the code and copied and pasted it into the right place.
How does it handle multilingual vowels?
That's a good question. In theory, it should work because I'm doing a binary match on UTF-8. Let's try it out and see what happens. Not there. I want to go to. So if I do Pig Latin, so if I do like, I don't know, what's a multilingual one? It won't handle multilingual vowels.
Yeah, they're kind of hard coded on line 24.
Jose's name, Jose Villim, because how do you spell his name? He's got an
What about
accent with an E.
Eclair? How does that cope with that?
Yeah, let's do.
You just have to extend your vowel list and that would work.
Yeah, if you extend it out, that would work. Let's do that. I'm pretty sure the entire reason Elixir was invented was Jose wanted actual proper Unicode support in a language. Yeah, so in that case, what's it done there? Actually, that's not going to make a difference. Well, it is right because it's going to go to the J first and then the O, and then say I'm done, and then just kind of append this together. But if the E was in the second place, it would be a different story. So let's see if we do. I'm having to like copy stuff here because I don't know how to type these characters in. Let's say his name is Jesse Villim. That will probably do. What's it done in that case?
I think it's treated
it also doesn't handle
consonant cluster.
Yeah, it doesn't handle uppercase. So if I do let's say it looks like that. Yes, what's it done there?
It's treating the E's as a consonant.
Yeah. So that thinks the E's are consonants, but I would have thought that in that case there, the J would have put the whole thing at the end. Because with the consonant cluster, it's supposed to put it all in there.
But the whole thing, with including the E's, is a consonant cluster, so it ends up just putting it on the end.
That's true, yeah. So if we did, yeah, I'm trying to think of one where you'd have that coming up as a thing. Actually, let's try that. Do it like that. And again, it's treated the whole thing as a consonant cluster. Let's do that. Yeah, so it gets weird with it. So yeah, if it was extended out, so the vowel list was having all the code points for things that are considered to be vowels in different languages. There's probably text analysis libraries that might do that for you, but yeah, I'm not hard coding it.
I'm not even sure it's Pig Latin at that point. It's not supposed to be multilingual.
Definitely getting to edge cases. I mean, it doesn't blow up with Unicode anyway, so that's a good thing.
And it's Pig Latin American.
Yeah, like if you did do that, like the naive way that you could do this would be to match just on 8 bits there, assuming everything's ASCII. in that case, yeah, things would probably blow up on you. But if you use the UTF-8 match, or type in a binary match, then you're kind of safe. It'll actually pull in characters with the right, byte size, whether it's 2 or 3 or 4 or 1 bytes or whatever.
Awesome. Nice one.
Cool.
If you post it soon, it'll be next to my one. I did it earlier today.
All right, I should get that set up and do that. I have to find my login for it and do that. I'll do that after this.